Welcome to another tutorial. In the previous videos, we've seen how to plot the function f of x equals to x squared with a having the value of 1. We've also further used this function f of x equals to x squared as a base function against which other functions were compared to. We also looked at how to plot the function f of x equals to 2x squared with a having the value of 2. This function was used as an example of plotting a function with a having a value greater than 1. We moved on to plot the function f of x equals to 0.5 x squared with a equals to 0.5. This function was used as an example of a function having a value of a between the values of 0 and 1. Now we're going to show you how to plot the function f of x equals to minus x squared and the function f of x equals to minus 0.5, both of which have a value less than 0. The following graphs are the graphs of the functions f of x equals to x squared, f of x equals to 2x squared, and f of x equals to half x squared. The green graph, as we've seen in the previous video, can be drawn in the manner given, with our three coordinates being minus 1 and the 1, a 0 and a 0, 1 and 1 for the function f of x equals to x squared. And for the function f of x equals to 2x squared, our three coordinates are the x coordinate is minus 1, the y value is 2, the second one is a 0 and a 0, the third one is a 1 and a 2. And we can see that our function f of x equals to 2x squared is steeper than the function f of x equals to x squared. And our function f of x equals to 0.5 is the outermost graph, which is wider than the function f of x equals to x squared. Yes, our function f of x equals to x squared. The three coordinates are minus 1 and 0.5 for the function f of x equals to 0.5 x squared. The second coordinate is 0 and 0, and the third coordinate is a 1 and a 0.5. That is for the function y equals to half x squared. Now let us see how to plot our fourth function on the same system of coordinates for the function f of x equals to minus x squared. This function is similar in shape to the function f of x equals to x squared, except that the y value is negative. That is, instead of having the y value for the first coordinate minus 1 and 1 to be 1, it's now gonna be minus 1. So this is our first point. And our second point is 0 and 0, as we've seen previously. And our third point would be 1 and a minus 1. You can convince yourself of these figures by using the system we've used previously to do the calculation for the y value. You will see that the resulting y values will be negative because of the negative sign in front of the x squared. And when we plot the graph, we'll get our function having the shape as shown. And this function will represent the function y equals to minus x squared. Now we can see that the function of f of x equals to minus x squared is simply a reflection across the x-axis of the function y equals to x squared. That is the function drawn in green. It is simply a reflection of the graph y equals to x squared. Let us move on now and draw the function f of x equals to minus 0.5 x squared. Our first coordinate will be, you probably guessed it, it's a minus 1 and a minus 0.5. And our second point is a 0 and a 0. And our third point is 1 and 0.5, which is a point somewhere around here. Let us now connect our 3 points to get our graph. Go to 0, and we go to 0.5, and moves on. Similarly, you can see that the function y equals to minus 0.5 x squared is simply a reflection of the function y equals to minus half x squared across our x-axis. Now, we can see the impact of a having the value less than 0 on the graph of a parabola. We see that the graph of a parabola, if the a has the value less than 0, is actually facing down, whereas parabolas with a values greater than 0 are facing up. That is, a parabola with the a value greater than 0 faces up. This is a parabola with the a value greater than 0. Whereas a parabola with the a value less than 0 faces down. This is the end of our video on the impact of the value of a on the graph of a parabola.